Okay, here you are given the function g of t, which is equal to 1 over the square root of t. We want to be able to find a derivative of the function using the definition of a derivative. Now recall that the definition of a derivative is the function g prime of t, which is equal to the limit as h approaches 0 of g of t plus h minus g of t divided by h. So we want to find the limit as h approaches 0. So the first function is going to have the input of t plus h. So we have 1 over the square root of t plus h, and then minus the function g of t, so that's going to be minus 1 over the square root of t, and then we're dividing that by h. Okay, so we might need to find a common denominator here. So we have 1 over the square root of t plus h minus 1 over the square root of t. So we would say that the LCD, or the lowest common denominator, is the square root of t plus h times the square root of t. So that means we're going to have our new denominator over here, which is the square root of t plus h times the square root of t, minus over here the square root of t plus h times the square root of t. So what that tells us is, what do we need to multiply by this, the first fraction, to get the new denominator? We got to multiply this by the square root of t, and then multiply this by the square root of t, so we have the square root of t in the numerator. And then we're going to multiply this by the square root of t plus h, multiply that by the square root of t plus h, so we have the square root of t plus h. And so now let's go ahead and simplify that just a little further. And so we get the square root of t minus the square root of t plus h divided by the square root of t plus h times the square root of t. So over here, we're going to continue in our limit as h approaches 0. So in the numerator, we have the square root of t minus the square root of t plus h over the square root of t plus h times the square root of t, and then we're dividing this entire thing by h. So we're going to continue to use algebra in order to then simplify our fraction. So technically, if we take a look at this fraction here, okay, we're just separating this. That means we're taking the square root of t minus the square root of t plus h over the square root of t plus h times the square root of t. And remember, we're dividing it by h. Okay, and if we're dividing that by h, it's the same thing as changing this to the reciprocal. So that means we're multiplying it by 1 over h. And so then what we get next is the limit as h approaches 0. So now in our numerator, we're going to have the following. We have the square root of t minus the square root of t plus h. And then we're going to divide that by h times the square root of t plus h times the square root of t, because we're multiplying those together. Okay, so now we have this limit. Okay, now what do we need to do next? Well, if we plug in 0, we get 0 times everything. So we're still inputting 0, so we still need to figure out what can we do here. Well, the next step is we want to multiply the numerator and denominator by the conjugate. So we're going to multiply the numerator by the square root of t plus the square root of t plus h divided by the square root of t plus the square root of t plus h. So we're rationalizing the numerator, so we're going to multiply those together, and then we'll multiply the denominators together. So if we multiply the numerators together, we're going to get the difference of squares. So that means we're going to square the first term, which is the square root of t, and we're going to square that, minus the square of the second term, which is the square root of t plus h. So now when we square the first term, we get the square root of t squared, which is t, minus, now we have two terms under the radical. So when we square the radical, we get t plus h. Now when we distribute the minus sign, we get t minus h. And what's left is negative h. And therefore, that's what's going to go in the numerator. So we have the limit as h approaches 0 of negative h divided by, in the denominator, we have h times the square root of t plus h times the square root of t times the quantity, the square root of t plus the square root of t plus h. Okay, so what can we do next? Well, you can notice that we can simplify the h. So when we simplify the h, here we have 1 left in the numerator, which is a negative 1. So we have the limit as h approaches 0 of negative 1 divided by the square root of t plus h times the square root of t times the square root of t plus the square root of t plus h. Okay, now when we evaluate the limit, we get the following. We know that h is going to be 0 here, and it's going to be 0 here. So let's go ahead and evaluate that limit. So we have negative 1 in our numerator. And so we have the square root of t times the square root of t times the square root of t plus the square root of t. So let's simplify this a little bit more. We get negative 1. Well, the square root of t times the square root of t is t. And then we're adding those together. So that is times 2 times the square root of t. So we don't want to need the two terms of the t in the denominator. So if we take 2 times t, and the square root of t is the same thing as times t to the 1/2. This is the same thing as 1, which is the same thing as 2 over 2. So we end up getting 2t, and then you add the exponent, which is 3 over 2. So this is equal to negative 1 divided by 2t to the 3/2. And so therefore that's going to represent our derivative function. So next question wants to find out is state the domain of the function, which was the original function, which was 1 over the square root of t. So the original function g of t is equal to 1 over the square root of t. Okay, so what that tells us, since this is in a denominator, the value of t has to be only greater than 0. Okay, so that means that on the number line, we know that from 0, we have parentheses, and it's going towards positive infinity. So the domain of this function goes from 0 to infinity. Okay, now let's find the domain of the derivative. So the derivative g prime of t, we end up getting negative 1 divided by 2t to the 3 over 2. Now we can rewrite this in another way. This can be -1, 2, and that is the square root of t cubed. So that means we need to find out when, since this is a even root, we cannot let this denominator equal 0. So that means we want to set t cubed to be greater than 0. If we cube both sides, or we can raise each side of the inequality to the 1/3 power, so we end up having t, which is greater than 0, and therefore we end up getting the same result as the previous one. That means the domain is also going to go from 0 to infinity, but we cannot include 0.